Thank you so much for the warm welcome. Thank you, Vultr, for having us here. So excited to be at GTC 2025. Let's go, baby. GTC. No, no. So I want to shout out Vultr for having us, the largest private cloud provider. And I am here with Quadrant. We are a vector database. If you're not familiar with vector databases, what vector databases do is take unstructured data, turn it into numbers, and then allows you to run classical machine learning or AI techniques on that data. So here we have a sentence from 2001: A Space Odyssey, one of my favorite movies. I'm sorry, Hal, you can't do that. So we have this sentence here, and the idea is, what if you wanted to search and find this information? Well, what the sentence comes out to is actually astronaut floating in space. And the way that Quadrant does that is by turning that data that we see here in the paragraph into numbers. But it's not just text, right? You see here, we also support PDF, CSV, images, video, music. Any kind of data that you have, whether it's structured or unstructured, you can search, recommend, you can do anomaly detection. You can also do Q&A over your documents using Quadrant. Now, you might be thinking to yourself, okay, this is awesome. We love vector search. Where does Vultr come in? Well, part of doing anything that you're going to need for the vector search for these agentic AI tasks that Vultr mentioned is going to be embedding your data. And you can use the Vultr cloud to do this process and speed it up. So Quadrant is already fast. Vultr's fast. You put them together, you get super fast AI. Now, what can you do with this super fast AI? One example is e-commerce recommendations. So imagine you're a large e-commerce store and you have a bunch of items. You want to make recommendations to your customers based off of what they have in their cart, what they clicked on, or maybe what they purchased in the past. Quadrant is going to allow you to upload your data as it is without having to do any kind of special manipulations with your unstructured data. You can just go ahead and upload your entire database of products, and Quadrant will figure out how to make the recommendations on our own. And you'll put that data in using Vultr's cloud service, which is what's going to make it run really fast. So we have a demo that we have built that we're showing off at our booth here that you can see. And that demo is the e-commerce demo where we uploaded 25,000 pictures of clothes from H&M, and you can search through that by typing in something like formal or casual. We didn't tag the images as being formal or casual. Quadrant just looks at the image, it sees that it's a t-shirt, and decides, that's closer in vector space to casual. So when the user searches casual, I'm going to return that. You can imagine that could be a PDF or it could be a video. The idea is you can search, do recommendations, Q&A, anomaly detection, all that good machine learning stuff on traditional data. The other demo that we have, and this is going to show you the private cloud, which is another thing that you can do using Vultr, where all your data is going to be kept on your platform. So you maintain data privacy and data sovereignty, as well as making sure that no data goes in and out. So the only data that's going to be coming in and out is telemetry data to let you know whether your cluster is healthy. Other than that, it's all local. We are SOC2 compliant. We work with pharmaceutical, government, defense, legal. So your data will be private, and you can do this all using Quadrant and Vultr to make sure that it's super powered. So we have this demo here for cancer detection, and this is an application that someone in the medical field might use to do a preliminary diagnosis or maybe a triage on which patients actually need further evaluation. So you're going to upload a picture here that we have of a piece of skin, and Quadrant's going to tell you by looking at similar pieces of skin whether those people had cancer or not, and then combining that with DeepSeek, a local model, whether or not the user has cancer. So to bring it all together, basically, you can think of it as Quadrant is going to be the piece in this process right here that is going to take the data and turn it into numbers, but that indexing process is one of the most expensive and time-consuming processes of AI. So when you power that up with something like a cloud GPU, all of a sudden you can do it super fast, get your results, your search, your recommendation out almost immediately. And the other nice thing about this relationship is it's flexible. So we've worked with Vultr to make sure that whatever deployment system you need, We're going to support it through Quadrant and Vultr. We support customers that are deploying billions of vectors, so huge scale, and Vultr is really cheap. So when you start looking at that price to performance ratio, you're just not going to be able to beat it with anything on the market. So that's why we love Vultr over here at Quadrant. Going back to the demo here, I just wanted to quickly show you this embedding model that we're using for the demo. It's Dino V2 Visual Transformer. This is a really large embedding model. And what the embedding model is going to do is it's going to be able to take an image such as what we have up here, these pictures of cancer or potentially not cancer, and it's just going to be able to look through that image and tell you, is that picture closer in latent space or vector space to someone who has cancer or someone who doesn't have cancer? And based off of that, we can all of a sudden make a prediction on whether or not the patient has cancer. Now, the problem or the bottleneck, you will, in this process is that embedding model, the Dino V2 that I mentioned, because it's a large model that needs to first take the image. And if you imagine, go back to your colors, there's RGB code, right? So every single pixel has a value for R, G, and B between 0 and 255. You can imagine a picture like this might have a lot of different pixels, right? So what Quadrant needs to do is literally decode every single picture, what the embedding model needs to do is decode every single pixel and turn that into numbers. So that's a very expensive process, which is why when you can speed that process up with the GPU, all of a sudden you're going to be cooking with some hot grease. You're going to get your results out a lot faster than if you were doing it on the CPU. So that's why we partnered with Vultr to show these two demos, not only this demo, but also the e-commerce demo, right? The reason why this is a great example of why you might want to be using something like Vultr is if you have 25,000 images in your product catalog and you want to embed all of those images and build a recommendation system, it's going to take you a long time if you're trying to do those embeddings on the CPU. Switch over to the GPU. That's why we love NVIDIA. They're going to be accelerating all of our processing. All of a sudden, we're going to find 10x speed improvements. So quickly here, I want to show you a little bit of how this image actually looks. So if you take a look at the image up here, you can see all the different samples of skin cancer that we uploaded to the Quadrant collection. And then you can also see our image, which we've highlighted over. So that is how in vector space, don't get lost in vector space, right? By using Quadrant, you can make sure that you know where you are in vector space. And if we look at that image, we can see, the cluster that it's in is clearly a cluster that is around other images that have cancer. We can deduce that this patient has cancer. So, in terms of the private Gen AI architecture, so this is one way that the process might come together in order for your agentic AI app to work. You got your source data. That might live somewhere like Hadoop. It might live in a Google Doc. It might live in a CSV offline. Then you got your private embeddings. In our demo, we use Llama Index. And the beauty of the private embeddings is, once again, going back to that slide where I talked about the Dino V2, the private embedding means all that data that it has about your images never leaves your premises. So if you're working with sensitive data, whether that's medical, you got HIPAA, whether that's government, SOC, whether it's legal and you have clients, we're going to make sure that that data doesn't get out anywhere using those private embeddings. And then we're combining that with a secure data stream, right? So you could use something like Redpanda that offers this secure data stream, once again, making sure that all the information during the AI process stays private, you have data sovereignty, and you have full control over your data. Then, in terms of retrieval, this is where we're going to talk about the Quadrant piece, where not only do we have the monitoring, hybrid cloud, encryption, access control, sharding, and multi-tenancy, all of that is going to be powered by the Vultr Cloud, which is going to supercharge everything 10 times faster is what we saw in our test. And then finally, we've got the generation. Once again, we're using a private LLM. So in our example, we're actually using DeepSeek LLM, which is a fairly new model that got released, completely open source. So you can see all the code. You know exactly what's going on. You don't need to worry about your data. So that is the presentation. Thank you all so much. If anything you take away from this, remember, scale, price, flexibility, performance, and private. Love Quadrant, love Vultr. Check us out at the booth over here. Thank you all for joining us.